The Mariana Trench is the deepest oceanic trench on Earth, located in the western Pacific Ocean. It is renowned for its extreme depth and unique environment. Location: east of the Mariana Islands, near Guam in the Pacific Ocean. Length: approximately 250 kilometers, 180 miles. Width: about 69 kilometers, 43 miles on average. In depth, the deepest part of the trench, called the Challenger Deep, reaches approximately 10,984 meters, 36,037 feet, below sea level. The trench is a result of subduction, where the Pacific Plate is being forced beneath the smaller Mariana Plate. This tectonic activity has created the vast trench over millions of years. The Challenger Deep was first measured in 1875 by the HMS Challenger expedition. In 1960, Jacques Piccard and Don Walsh descended to the Challenger Deep in the bathyscaphe Trieste. In 2012, filmmaker James Cameron conducted a solo dive in the deep-sea Challenger submersible. Since then, various other missions have been carried out using advanced robotic submersibles and manned vehicles. The pressure at the deepest point is over 1,000 times atmospheric pressure at sea level, roughly 16,000 pounds per square inch. Close to freezing, typically 1 digs, 33.8, 39.2 digs. Total darkness due to the depth preventing sunlight from penetrating. Despite harsh conditions, life thrives here. Microbes, amphipods, sea cucumbers, and xenophyophores, giant single-celled organisms, have been found. Nearby, these vents support unique ecosystems with chemosynthetic organisms that derive energy from chemicals rather than sunlight. The trench is a hotspot for studying extremophiles, organisms that thrive in extreme conditions, provides insight into subduction zones and plate tectonics, plays a role in understanding deep-sea carbon storage processes. Studies reveal the presence of pollution, including microplastics, even in these remote depths. The Mariana Trench was formed by the subduction of the Pacific Plate beneath the Mariana Plate. This occurs at a convergent plate boundary, where one tectonic plate slides under another. The trench is a result of tectonic activity over millions of years. As the oceanic crust of the Pacific Plate is forced down into the mantle, it forms a deep depression in the ocean floor. The deepest part, the Challenger Deep, is located at the southern end of the trench. It reaches nearly 11 kilometers, 7 miles below sea level, making it the deepest known point on Earth. In addition to the trench, there are volcanic arcs formed by the melting of the descending plate, resulting in volcanic islands like the Mariana Islands. The HMS Challenger expedition in 1875 was the first to take soundings of the trench using weighted ropes, measuring its depth and mapping its outline. In 1960, the first manned descent to the Challenger Deep was made by Jacques Piccard and Don Walsh in the bathyscaphe Trieste. They reached a depth of about 10,911 meters, 35,797 feet, and spent about 20 minutes on the ocean floor before returning to the surface. In 2012, James Cameron, the filmmaker of Titanic, made a solo journey to the Challenger Deep in the deep-sea Challenger submersible. He reached a depth of 10,908 meters, 35,787 feet, capturing video footage and collecting samples from the deepest part of the trench. More recent expeditions use autonomous underwater vehicles, AUVs, and remotely operated vehicles, ROVs, to explore the trench's depths without the risks of manned missions. Despite the extreme conditions, life exists in the trench, though it's very different from life in the sunlit parts of the ocean. Microorganisms. Tiny bacteria and archaea thrive in the trench, surviving by chemosynthesis, using chemicals like methane or sulfur for energy, rather than photosynthesis. Amphipods. These are shrimp-like creatures that live in the trench. In 2017, scientists discovered a giant amphipod species in the trench that can grow up to 30 centimeters, 12 inches long. Xenophyophores. These are massive, single-celled organisms that grow in the depths. They play an important role in the trench's ecosystem by acting as a substrate for other organisms. Fish and sea cucumbers. Several species of fish and sea cucumbers have been observed living at extreme depths, adapted to survive in high-pressure and cold environments. Hydrothermal vents. These vents release mineral-rich water, supporting unique ecosystems that rely on chemosynthetic organisms. The species living here are often adapted to withstand extreme temperatures and pressures. Adaptations. Species in the trench have evolved to survive without sunlight. They often have large, sensitive eyes, or no eyes at all, slow metabolisms, and specialized mechanisms to deal with the crushing pressure and frigid temperatures. Pressure. At Challenger Deep, the pressure is over 1,000 times the pressure at sea level, or roughly 16,000 pounds per square inch. This immense pressure would crush most human-made vehicles and marine life, but specialized equipment like the Trieste and Deep-Sea Challenger are designed to withstand these conditions. Temperature. The water temperature is near freezing, around 1 to 4 degrees, 33.8 to 39.2 degrees. Organisms living here must be adapted to cold environments, with slow metabolisms and unique biological adaptations for survival. Lack of light. The trench lies below the photic zone, meaning no natural light reaches this depth. Organisms here rely on other sources of energy, like chemicals from hydrothermal vents, rather than sunlight. The trench plays a role in the global carbon cycle. Organic material, including plankton and other organisms, sinks to the ocean floor where it is eventually trapped in the trench. This process may help store carbon deep below the ocean and contribute to the Earth's carbon balance. Scientists are constantly discovering new species in the trench. The extreme conditions provide a laboratory for studying how life can adapt to harsh environments, and it may offer clues about the possibility of life on other planets with similar conditions. The trench provides insight into the process of subduction zones, where one tectonic plate dives beneath another, causing earthquakes and volcanic activity. Researchers use the trench to study the dynamics of plate tectonics and the creation of the Earth's crust. Despite being one of the most remote places on Earth, the Mariana Trench is not free from human influence. Studies have found evidence of pollution at great depths. Microplastics. In 2016, scientists discovered microplastics in sediment samples from the trench, a reminder of how pervasive plastic pollution has become, even in the most isolated ecosystems. Chemicals and metals. Other contaminants, such as toxic metals like mercury, have also been found in the trench. These pollutants can accumulate in the trench's ecosystem, posing a threat to deep-sea life. Waste from ships and fishing. There have been reports of discarded fishing gear and other debris finding their way into the trench. Manned submersibles. Vehicles like the Trieste and Deep-Sea Challenger are specially designed to withstand the immense pressure at such depths. They use reinforced, thick walls made of materials like titanium or special glass to protect against crushing pressure. Remotely operated vehicles, ROVs. These unmanned vehicles are often deployed from ships to explore deep-sea regions, collect samples, and capture video footage. Autonomous underwater vehicles, AUVs. These robots operate independently and can cover large areas of the trench without needing a support ship. They are used to map the ocean floor, study ecosystems, and gather data on temperature, salinity, and pressure. Sonar and echo sounding. Scientists use sonar technology to map the trench's contours and measure its depth, revealing new features like underwater mountains, ridges, and underwater volcanoes.